And the artwork was this. I am super excited to have our next guest come up. He and I had crossed paths quite some time back, and it is absolutely my pleasure to have him join us today. So, what I'm going to do is I'm going to remove that. I'm going to do this, and I'm going to do this little countdown like I always do. And I'm going to say three, two, one. And out of nowhere, we have our next guest appear, Mr. Jon Sneyers. How are you doing?
I'm good, thank you. Thank you. And thanks for having me, Ari.
It's a pleasure, and I really do mean that, it's a pleasure. Um, for those out there who may not know, because I haven't done one in a while, but a few years ago, I was a bit of like an image asset, image technology, fanatic. I was reading a bunch of books, trying to be up to date. But a few years ago, a couple things happened actually. A few years ago, I did these streams called Image Ready, which were a lot of fun. They were just right around the pandemic. I was like, man, let's just do some stuff online, and it turned out to be much more entertaining than I thought it might be. So super happy. But also, Cloudinary had organized these things called ImageCon, which were these sort of like uh, you know it was a conference literally just about images and image technology and all things in between. And I met Mr. Snares there, and we've just not seen each other in a long time. So once again, I'm delighted to have you join us. Let me clear the stage and allow you to introduce yourself.
Right. So I'm from Belgium, um, but I'm working for the company called Cloudinary for 10 years now, as the only Belgian, by the way. Um, and what I'm doing there is research on image processing, image compression. Um, so for quite a while now. Um, And as part of that, I've been privileged to work on JPEG XL, which is the next generation codec by the JPEG committee. Um, so I've been involved in everything about it, from the design to the current stage of implementation and deployment. Um, I've been the editor of the standard itself. So that's ISO IEC 18181, parts 1 to 4. Um, and I've been active in the ad hoc group within the JPEG committee that is taking care of JPEG XL. Um, I've also participated in developing the reference implementation, libjxl. Um, I'm currently a little bit involved in the Rust implementation, JXL-RS. Um, but yeah, so anything JPEG XL is, uh, yeah, I've been closely involved in. But yeah, there's other things related to images that I do at Cloudinary, all kinds of stuff. I'm currently mostly interested in image quality assessment. Uh, and there's two kinds of it. There's no reference and there's full reference. So no reference means you have to assess the quality of an image, but you don't know what the original looks like.
Mm.
That's a hard problem that I'm currently working on for Cloudinary. There's also full reference, which is the fund of quality assessment you need to assess whether the codec is being good or not. So I'm interested in objective metrics that you can develop. I'm interested in subjective testing methodology. This is also an activity that is going on in the JPEG committee for quite a while now. It's called the AIC subgroup or auto group, um, which is assessment of image coding. Um, so yeah, those are my main topics of interest.
Now, you've been working at Cloudinary now 10 years. Did you work, is there, is this something that you want to mention where you were before Cloudinary? Did you come from academia?
Yeah, I mean, this all basically started as a pet project back at university. When I was doing, I did my PhD on something completely unrelated, which is optimizing compilation for niche declarative programming languages. So very unrelated. Uh, but during some postdoc work, there was a pet project, actually, together with my colleague Peter Ruelle, who was at the same office. Um, and yeah, we got interested in image compression, lossless at first, later also lossy. In the beginning, it was just a pet project, but it turned into what became FLIF, the free lossless image format, and that was actually a precursor of what would become JPXL, one of the precursors. So yeah, it started probably 15 years ago, um, and then 10 years ago I started working for Cloudinary, and the pet project became the main project, let's say.
Amazing. So basically what I'm hearing is that you went from literally, academia, working on your PhD, right into working for Cloudinary thereafter.
Yeah, I mean, there was I did my PhD in 2008, so there was um, a period of postdoc. I also was a guest professor for some courses and so on for a while. But yeah, in 2016, I joined Cloudinary. Almost exactly, well, 10 years and 2 weeks ago.
No one's counting. Uh, and I guess you got 10 years and 2 weeks ago. So did you celebrate in Australia? We'll get to that soon, folks.
Yeah, I mean, there was a JPEG meeting in Sydney. Um, yeah, roughly at the time I was working for Klein for 10 years. Um, and it was a nice meeting also because we just heard the news about Chrome adding support. So this um, actually on the first day of the meeting, this was known. Yeah, was an interesting JPEG meeting. I've been to all of the JPEG meetings since 2018 when we started the work on JPEG XL.
Mhm.
And of course, the JPEG XL itself is now for the JPEG committee in a kind of maintenance mode. It's now most of the work is done. We're still making revisions of the standard and updating it, but it's not the huge activity anymore that it used to be when we were designing the codec, obviously. So currently at the JPEG meetings, I'm mostly looking at the work that's being done there on image quality assessment, which is still an important thing. But I'm also keeping an eye out for the other activities like JPEG Trust, which is I think a very important project on provenance and being able to have this metadata of what where an image comes from. Can you trust that it is actually genuine, or is it something AI generated or manipulated in some other way? There's other interesting JPEG projects like JPEG DNA. They are trying to store images in DNA. There's JPEG XE, which is a event-based codec, so it's very high resolution in time. Um, but very sparse images. So it's not like slow motion video, but it's more like individual pixels telling that they're changing from dark to bright or the other way around. Um, and this is, yeah, a totally different concept of what an image is. It requires new types of codecs. There's JPEG Plano. They are working on all kinds of 3D things, point clouds, light field, all kinds of things. There's plenty of activities. JPEG AI, obviously making an AI-based codec, and so on. So it's an interesting place to learn about what's new. Um, but of course also to maintain JPEG cell.
Absolutely. Absolutely. And, you know, thank you very much for that sort of summary of some of the things that are taking place over at the committee and, what is being discussed at the meetings. And folks, what we were talking about right there is that the JPEG organization will have these meetings on an annual basis, some in person, some online, but they literally talk about a lot of the, you know, required technology to sort of have improvements in the JPEG, but also, as Jan just mentioned, in light of the new environment that we are in, there are some concerns around images, and he had mentioned provenance, something that's been of discussion for quite some time now, for a number of reasons. But we could that could be an entirely separate episode. Um,
It's actually it's not annual. It's 4 times a year that they have it,
Okay.
every 3 months. And since COVID, it's no longer every time physically. It's usually 2 times physical, 2 times virtual. But
Mhm.
yeah.
Awesome. So A as many know in the stream, after, we hear about, your sort of like work background and whatnot, we always like to ask the one question. And, as much as I feel like I know the answer, but, if you had to go back and, sort of like look at your own sort of history and, share when you felt the need or interest to work on, image compression. Um, do you remember if it was some event, something you read, uh, what made you realize that you wanted to sort of like do more research in this space and contribute to the space?
So I think the first idea started when I realized that. So let me give some context. I was working in a lab called Declarative Languages and Artificial Intelligence. Um, it has existed for many decades. Um, I wasn't doing, by the way, any of the deep learning type of AI. Was back then more of a symbolic approach, not statistically. So more based on logic and um, decision trees and rules and things like this. Um, so, but anyway, whatever the type of AI is, I realized that basically compression and AI are somewhat related in the sense that if you have a latent representation, whatever form it takes, that is summarizing in a way the information, then you can also use that to compress better. So that was where the idea started to use. I don't want to get too technical, but to use decision trees um, to create the context model for the entropy coding when doing compression. So that was I think the core idea of Fliv. Um, but basically, the main insight was that if you can somehow summarize the information or have some representation, some latent representation that makes sense, then you can also use that for compression. And so basically, the pet project was kind of exploring that idea of can we improve upon what exists? And it turned out that actually you can improve over like ping or whatever existing lossless codecs quite a lot by doing this type of thing. Um, so yeah, and that's when I first started doing stuff with images, and it was just too much fun compared to other things because it's so visual. You can see what you're doing. When you have a bug, you get this glitched image and then you can try to decipher what kind of bug you have introduced by having some kind of glitches. But everything is visual by definition. So uh, especially when you get to lossy compression, where there's also a difference between the compressed image and the original, um, it, it's always very visual.
Yeah, absolutely. And, I've always felt that the interest in images, had just driven so much on the internet, from experimentation to even, making sure that the right image, um, like the a good set of images will always create the engagement, right? And it's been very interesting watching along the way how important, image fidelity was. You talked about making sure that compression, and you mentioned something else. SSIM. What does that stand for again?
SSIM is a structural similarity. Uh, so it's one of the metrics that is being used to assess the fidelity of an image. Yeah.
Oh, yeah, I was thinking like Fidelity, and I was like, there might be something else, but I always remembered like SSIM and whatnot. But, just reading all the interest and the research that has gone into images was kind of fascinating to me because, it made seem like so trivial to some people, but, I would remind them about all the work that went in to them being able to look at a high quality image on their device, like it's just not that easy. So let's get into the idea of the JPEG Excel. So you've done, you were doing some PhD work. You found, working on image compression and codecs a lot of fun. Because there was just kind of like really interesting visual feedback of how well you were working or how things how wrong things were going. At what point, how does the JPEG Excel conversation even come up?
So I think my first contact with the JPEG committee was in 2016 when um, JPEG was holding this. They call it the Grand Challenge on image compression
Mhm.
for evidence of new technologies. Um, and this was a challenge. I submitted FLIV back then as a contender, but it could only do lossless, so it was only in this specific track of lossless compression. The main focus was on lossy. But anyway, the conclusion of this challenge was that yes, there is new technology, there's new things that can happen. And then in 2017, they created the call for proposals, or the first drafts of the call for proposal for JPEG XL. They already picked a name, even though the codec didn't exist yet. Um, and so yeah, but this was when I decided, yeah, maybe I can contribute to this and make a submission. So I took FLIV and I changed it up to also be able to do lossy. So that's how it became FWIF. The instead of lossless, it's universal. Uh, Vicious name, but anyway, the nice story is that FWIF. I'm pronouncing it in English now, but actually it's vijf, which is a Dutch word that means party. Um, so anyway.
I this now, right? Because I was like, "Oh, yeah, I remember reading this." Yeah, 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 yeah. Comes all these things come back. But anyways, I didn't mean to interrupt.
Oh yeah, and then in 2018 they had the final call for proposals. I submitted my proposal. There were other proposals. One of them was by Google, the team in Zurich, that they proposed what they call PIC for
Mhm.
picture, I guess. Um, and this was a more traditional DCT-based lossy codec, but they incorporated into it a lot of the lessons they had drawn earlier from making the Butter-Oakley metric, which is one of these fidelity metrics, uh, and also from Broadly and Lossless WebP, which were projects they worked on before. Um, so basically, they managed to improve the entropy coding a lot to get better compression, even if the data is the same. And they also managed to make a much better encoder in terms of fidelity, um, using a better color space and so on. Many things, extending the DCT to work with larger blocks as well. Um, Lots of new ingredients, but essentially all still based on the old JPEG. Um, and so in the end, the committee decided to take both my proposal and their proposal as the starting point, which is quite unique. Usually, when there's a call for proposals, there's one proposal that becomes the starting point for the new standard. But the two proposals are kind of complementary. So my approach was something completely different that became the modular part of JPEG Excel. Um, and it's particularly good for lossless, not surprising because it comes from FLIF. Whereas the part contributed by the Google Zurich team is more of an extension of the old JPEG, which also allows to recompress existing JPEG files seamlessly. So you can. This is an important problem if you have new formats, because a lot of JPEG files already exist, trillions of them exist, and what are you going to do with them? If you want to convert them to the new format, you have a problem, because, well, you have to do something. You have to either, well, you can compress it losslessly, but then you get a massive size blow up because it's like converting a JPEG to a PNG. Um, you are spending a lot of bits on encoding the artifacts in the original image. So that's not a good idea. I mean, it's going to become a larger file. So you can also recompress it in a lossy way. So you decode the JPEG to pixels, then you re-encode those pixels with the new codec. But then you get the problem of generation loss. So you have something that is already lossy, and you're basically like making a photocopy of a photocopy. You're adding additional artifacts by doing another round of lossy compression. So either you set the quality setting really high, so you don't get this problem that much, but then you still get the same problem of large file sizes, or you set the quality lower to reduce the size, but then this problem of generation loss gets even worse. So there is no good way to deal with it really, unless you have really high quality JPEGs to begin with. Then you can do lossy compression of them and still have something reasonable. But if the JPEG is already, relatively medium quality, you don't want to introduce any additional artifacts in that case. Um, so this is a key problem that is solved by JPEG by being a strict extension of the original JPEG. So everything that you can do in the original JPEG, you can also do in JPEG, um, which means that converting from JPEG to JPEG can be done in a way that is reversible. So in a way that you can get the actual original JPEG file back bit for bit. Um, so not just visually lossless or whatever, but it's just the exact same data encoded in a different way with better entropy coding so that it becomes a smaller file, uh, about 20% smaller if you do this operation, but with the guarantee that it's actually the same data, so that you don't lose anything. Um, so that's possible because of the approach that the Google Zurich team took by extending on the DCT approach. Um, but then, in terms of functionality, JPXL also has the other new things, like it can do lossless, which is something people generally don't associate with JPEG. Even though the original 1992 JPEG standard did have a lossless mode, but it was rarely implemented in practice. Browsers still don't support it, but it is something that is, for instance, used in DNG, the digital negatives. Um, so for storing raw images, there it is used as a payload codec. Um, but yeah, anyway, having the option of lossless and also having the option of higher precision, higher bit depth, so you can do HDR images, for instance, um, which is kind of a problem for the old JPEG, but also for instance, for lossy WebP or any 8-bit format. You just don't have enough precision to do HDR well. Um, so this is also something that JPXL resolves.
So essentially, and for those again listening and trying to get an understanding of the sort of like potential for the JPEG Excel at the moment, because you're sharing all this data about what is possible with the JPEG Excel. Uh, this is essentially presenting itself as ultimately kind of like a clear winner. Am I correct to make that assessment?
I mean, in the design of JPXL, we want it to be complete and have all the features, in the sense that one of the things we observed with previous attempts to replace JPEG was that they tended to miss something. So, for instance, WebP is not is an example of a codec that tried to replace JPEG, but they don't have all the features of JPEG. They cannot do progressive decoding, for instance. They cannot do 444, so no chroma subsampling. Um, so there are some built-in limitations, uh, that means that for in some cases you just cannot do it with WebP, and you still have to use the old JPEG. So we try to avoid that type of missing functionality, and we went quite far with that in the sense that there's even features from that would be more associated with image editors like Photoshop PSD or GIMP XCF files, where you can have layered images, like multiple layers that you can still uh, separate. They don't have to be merged into a single flat image. This is something that JPXL also supports. Um, or, for instance, CMYK. Um, this is only really used in print, but it's something that we support. While a lot of the new formats, like I don't know, WebP, AVIF, HEIC, they don't have support for this because it's not something you need in a video codec. Obviously, you're not gonna print a video, so they just don't have that functionality. So we try to be very complete in terms of functionality, so that not just do we have all the features, but we're also the best in terms of compression performance, uh, for all of these use cases: lossless, lossy, um, HDR, whatever.
Mhm. So I'm going to ask you something else as well, because this was certainly a topic that's kind of like dragged on for a number of years now. And then it just seemed that over the last year and change, there's been a significant change. Now, you'd mentioned just moments ago that you know the the idea of sort of like browser support came about, and the one thing that I used to tell people is that I felt that a lot of this innovation that was coming around images, and this could be incorrect, but this is how I was thinking at the time, that I felt like a lot of it was the innovation was driven also by um, the consumption online, the internet consumption of images. If you look at, like, I don't know, Instagram. I remember years ago I read this. They're saying that um, Facebook was really just like a picture app with comments, and this is like a long time ago, and the irony that Facebook would, acquire Instagram later made sense in my head. But that being said, when WebP came around, it was like, hey, the WebP's here, we're trying to do this. Uh, I remember when the WebP was introduced, the whole Mozilla project, they're like, hey, the JPEG's not dead, like let's work on it some more. And I just felt like so much more innovation was really driven by the idea of people sharing much more and the fact that they're sharing much more on the web. Would that feel sort of like a correct statement to you?
Yeah, yeah, definitely. I mean, I just pulled up a slide. If you can show it, maybe images have been dominating basically web performance for for a while now. So this is a at the bottom you see a plot of the median weight of a page,
Mhm,
um, as indexed by the HTTP archive. So we went in 2010 it was less than half a megabyte. Now we are at 3 megabytes at the median,
mhm,
but there's still also heavy pages that are more than 10 megabytes. And if you break down what this is made of, it's basically all images. Now also some video, of course, in some cases, but still predominantly images. And this is even an underestimate of the importance of images in the sense that um, you have your HTML, which is usually dynamic. You have the images, which are usually dynamic, and then you have CSS, JavaScript, and fonts, which also contribute quite a lot to the median page weight. But those are mostly not dynamic. They are generally static, at least for a while, and so they can be cached efficiently on the browser side. But the images, they are always new, and so this is what makes it so important in terms of how much traffic it causes. And yes, browsers have been driving uh, the need for better compression for a while, but I don't think it's the only it's only web pages. So it also just photography. If you look at, for instance, Google Photos, I read they are now storing over 1,000 pictures per person on Earth, so 9 trillion uh, photos. So we're adding globally about 2 trillion new photos per year. So this is 10 million terabytes worth of JPEG files mostly. Uh, and besides photography, there's many other use cases where images are needed. Uh, of course, computer games, but also medical use cases, satellite imagery, and so on. And they also all need to get better compression because here it's not so much that they want to improve the user experience on the web, but the amount of data that they have, the number of megapixels or gigapixels that they need to send, the fidelity and the accuracy of the images, um, the expectations are always growing as well. So I think there's many use cases that require better compression, not just the web. But yeah, the web has been playing a big role in promoting new formats. We've seen uh, Google's WebP, um, uh, which was, I think, released in 2010 for the first time. Um, we've seen Heek promoted by Apple. Um, Probably more for the photography use case than for the web, but still. And we've seen AVIF, and all three of them are based on video codecs. So the approach has been we prove video compression because that's also one of the main drivers of traffic, of course, and especially with the streamers like Netflix and YouTube and so on. They also have strong needs in better compression. So the idea was we're doing the research for video anyway, so let's just use single frame videos as an image format. It will compress better because it's more up to date. Um, but it's not an exactly an ideal situation to have the new codecs be driven only by browsers. You know, you get a lot of angry people when they see WebPs because it's for at least for a very long time it used to be that WebP works on the web but not anywhere else. So and it's even still today it's kind of like that. Um, so it's not enough if an image format works on browsers. Well, it is enough to solve the web performance problem, but it's not enough for the bigger ecosystem of working with images. And there's lots of software that needs to work with images. You want to be able to put an image from the web in your document or presentation or whatever. There's lots of applications that aren't necessarily about images, but they still need to deal with images. So having image formats that are only well supported in browsers, it's probably not a good idea. Um, and so, yeah, if you look at the JPEG Excel history, uh, we have been in terms of browser support, we've kind of been on a roller coaster. I have this silly slide about it somewhere. Yes, this one. Especially if you look at the support in Chrome. So we have been in Chrome behind the flag already in May 2021, which is incredibly early. This was like just a few months after the bitstream was frozen, but the standard was still being in the process of getting published. It was only published in beginning of 2022. So we got into Chrome quite early, but then we got removed from it again. So on Halloween 2022, there was this announcement that JPEG cell support would be removed from Chrome. Um, and this was a very big blow for the adoption of JPEG cell because if you're not supported by browsers, it's really hard to get broad adoption in general because so much is browsers. It's not just websites. There's also lots of applications that are essentially running in a browser. So if those applications want to use an image format, it needs to be supported by the browser. Um, and yeah, any kind of sharing of images and so on, it needs to be supported in the browser. It also needs to be supported in a lot of other software. Yeah, not being in a browser was a big problem. But so what happened after this was mostly that we have been getting adoption in all other areas up and running. So we got in all the image libraries, we got in all the OS level places where we need to be, all the image authoring applications, all the viewers, and so on. So to get a broad support, um, and also different use cases. Like we got, let me see if I have this. Yeah, we got into the DICOM standard, which is for medical images. In medical image sharing, they use the DICOM format, but it has a payload codec that is behind the scenes encoding the images, and so JPEG XL was added to it. The same with DNG for camera raw files. Um, the same also for PDF. PDF is now also going to have JPEG XL as a payload codec. So we kind of built slowly but steadily a more broad ecosystem support in various use cases. Well, one of the big points where things started to change was when Safari started supporting JPEG and the Apple ecosystem in general. So that was a very big thing. And then Mozilla decided at some point that they would change their position if there would be a Rust implementation of JPEG, they would consider to add it into Firefox. Um, so at that point, Chrome was basically the only one that was still saying, "Well, we don't need JPEG." Um, After about 2 years, a little bit more than 2 years, um, the Chrome team finally decided to reverse their decision and said that also similar to Mozilla, if there is a safe Rust-based implementation available, then they will consider it. And in fact, just 9 days ago, there was the release of Chrome milestone 145, um, which already has JPEG support only behind the flag at the moment, but we hope that that soon it will be enabled by default. Um, so this has been a bit of a roller coaster in terms of support. First, we had it very early, then we didn't have it for quite a long time, and now we're looking forward to having it again, and hopefully enabled by default. But I've tested it out, the version that is behind the flag, and it works wonderfully. All the features like alpha channel, lossless, lossy, HDR, animation, it can do everything. It's already working pretty well. The main thing that we're still working on is making progressive work better, which is a big feature of JPXL. Being able to show an image before the entire file has been transferred. This makes I think a very big difference for the user experience, especially if you're like on a mobile network that is a bit shaky, uh, or if you're like on the train and then you're in a tunnel and suddenly there's nothing anymore. If you then can at least see some preview of the images, even if they're not completely loaded yet, it makes a big difference, I think. And this is a feature that you really need to design a codec for. Um, and this is in particular something that none of the video-based codecs have, because this simply doesn't exist in video. In video, you never want to show a preview or a frame while the frame is still loading. It doesn't make sense because in video you need to buffer like a lot of frames anyway to get a smooth playback. Um, it doesn't make sense for video, but for still images, I think it does make sense. And so this is something that's still the decode side of it still needs to be implemented properly, but it is being done right now. So I hope that in a few months we will have a fully complete JPEG cell in Chrome. Yeah.
Awesome. Now, you talked about, the testing you done. Like I noticed it behind a flag. I didn't test anything myself, but you'd mentioned you've done a lot of the testing, so it looks good. Have you done the same for both Firefox and Safari? And I simply ask because I think Safari, if I'm not mistaken, because JPEG Excel, you have, and again, I could be wrong, you have animation capabilities.
Yeah, but Safari doesn't support that. Yeah, yeah.
Okay, and that's about that I'd seen as well. And what about
But I think that this is, I mean, this is not the strong point of JPXL. It supports animation because we needed to, we want to support all functionality. And in some cases, it can be good for it if you have like um, something non-photographic, like um, something that GIF used to be actually good for, which is like few colors, diagram type of illustration. This type of animation, JPXL can be good at, but for the vast majority of animations, which are like short looping natural video, um, you should just use a video codec.
Yeah,
And
absolutely.
Yeah, it doesn't make sense to use an image format for what is really video.
Mhm. I was actually also gonna say, one of the previous challenges, if I'm not mistaken, was the fact that, as much as that we may have had, say, opportunities to use other formats for whatever reason, say other image formats, and potentially do the same as they did with WebP or do the same as they did with um, AV1 creating a GIF. But a lot of them were not, um, oh, I don't want to say open source, but what's the word I'm looking for? Um, like the reason we're not using VVC or
Oh
VCC.
yeah, yeah, well, like the patents basically.
Right. Yeah,
Yeah,
and so, one of the, I think, keys here as well with, JPEG XL, there are no patents to deal with.
yeah, yeah. That's one of the things we really wanted to be clear about from the start. We we don't think there is a way to make a new image codec that is not royalty free and have broad adoption. Um, so
Want me to bring this thing onto stage?
yeah, I know it's not very important, but yeah, there's I mean this is something we share actually with AVIF, which is also made by the Alliance for Open Media, which has as a goal to have royalty free codecs. Um, so yeah, if you have a patent encumbered technology, it's okay for like Apple or any huge corporation, but a lot of people are not going to be able to use it if there's licenses to be paid. It's just also legally complicated to use it, even if you're willing to pay for it. So we designed it in a way that there's no patent encumbered technology in it. Uh, there are some new technologies in it that are patented by us, and we explicitly give a grant to the world to use it. Um, it's a similar trick that the AOM actually also uses. So it's we give a grant to use it uh, on the condition that you don't start suing people claiming that you have patents on JPEG XL. Because there's lots of patent trolls that, regardless of whether they actually have made inventions that are relevant, they will try to claim that they do and start litigating. And this type of behavior is it's really annoying, and people call them patent trolls for a reason. It's even if they're not right, and there's like clearly there is prior art and so on. It's just expensive to do the litigation process, and so more often than not, they can just intimidate people and make them pay for a settlement, even if it's all bogus. Well, anyway, with this defensive patenting, we can kind of try to prevent that in the sense that uh, if anyone tries to claim that they have patents on JPEG cells that are relevant, then they can no longer use our patents on it. So effectively, they cannot use JPEG cell anymore. So as long as you don't start trying to make JPEG cell not royalty free anymore, it is royalty free to you. So that's the methodology here.
Which is great. And, quickly, when you said, when we have, we actually have patents, um, this is we as in Cloudinary.
It's Cloudinary and Google. We both have declared. So it's in ISO. You have to declare if you're holding patents, uh, and we made a Type 1 declaration, which is we have patents that are relevant and they are royalty free. So everybody can use it. There's no license cost, um, but and you don't need to ask anyone. You can just use it. Um, but yeah, so There are other codecs that also have this, but then the companies make a type 2 declaration, which means I have patents and I'm willing to license them, but you will have to pay me. That's the type 2. And then there's type 3, but that rarely happens. That means I have patents, but I'm not willing to license them to you. Um, that basically means the codec is dead because nobody can use it, even if you want to pay for it. So that doesn't really happen, but type 2 happens frequently, and I mean in MPEG it's extremely common to have a huge amount of patents claimed on any codec they produce, whether it's HEVC or VVC. Um, so yeah, it's a different model, but yeah, for video maybe it can work in some way to do this, but I think for still images, there's no way to get a new format adopted if you want to also try to get rich from it. Nobody's is going to use it. I mean, Apple tried to do it with Heek, and they push it within their own ecosystem, but it's not going to go anywhere in terms of being a web format that is going to get big. Or maybe it will in time when the patents are no longer relevant, but I doubt it because by then it will not really be a very state of the art codec anymore.
Right. Right. So, um, if you were to, with regards to the JPEG Excel, if you were to sort of, you're having sort of conversation with just the ordinary individual, maybe even just a developer, and they'd asked you what the top three or maybe even top five features that you felt, really set the JPEG Excel apart from everyone else, what would they be in your estimation?
Um, so one I already talked about JPEG recompression. I think that's a very important feature in terms of preserving the legacy of images that already exist and having a path to transition. The next one I think is HDR. Um, I mean, we now have a lot of displays that are capable of displaying HDR. For video, it's being used a lot already. For still images, things are lagging behind a bit, and most of that is caused by the image formats because both the old JPEG and WebP are not capable of doing HDR. Well, I mean, the de facto JPEG, I have to say, because actually the original 1992 JPEG did have a 12-bit mode and so on. It could do HDR, but it wasn't implemented, and it's too late now to change the de facto standard. Um, so being able to do HDR, and uh, I think the third one is having a kind of set it and forget it way to encode images. So in the sense that you don't need to manually verify each time when you encode an image that the quality is okay, which is a kind of problem you have in many other codecs and in the old JPEG. If you want to save your JPEG, you typically have this slider for the quality, and if you want to reach a point where the file size is acceptable but the quality also looks good, you need to manually twiddle with it a bit. I mean, you can also just set it to very high quality all the time, but then the file sizes are not going to be very nice. Um, this is, I think, something that in at least libjxl implementation of the encoder really nailed down. It has this one setting for, it's not called quality. Well, you can also call it quality, but it's called the distance, the distortion amount that is acceptable, and it's measured in JND units, so it just noticeable differences. So you can set it to 1 JND or 2 JND or 3 JND. Um, but the meaning of this will be kind of the same, whatever the image is. So you can select the quality based on what you need once and then use it on all images. And you will get good compression while still getting more or less guaranteed quality compared to other codecs. So this is you could call it encoder consistency. So how consistent is it with the same settings to produce the same quality? And this is something where JPXL excels at. It's able to basically make the problem of image compression solved, in the sense that you no longer need to worry about, is the lossy compression going to ruin the image or not. Um, so I think that's, in terms of, practical usage, is an important one. How many did you say? Five? Where am I?
Whatever you felt
Yeah.
was
I
important.
mean, the ability to do lossless well, I think, is also important, because lossless, for web delivery, obviously you rarely use lossless, but for any kind of production workflow, you need lossless, and also applications that are more demanding, like medical, typically want to have at least the option of lossless. Um, and doing lossless in a way that compresses well, both for photographic and non-photographic images, I think it's useful, and it's convenient that this format can do that as well. Um, and then I think the progressive decode, I also already mentioned it, but I think for the web this still matters. We still have large images that can be the bottleneck of a page, and there's largest contentful paint metrics and so on that are trying to measure some aspect of this. But I think what matters the most from the user perspective is, when do you start to get to see what the page is about, so you know what your next navigation action is going to be. Are you going to go visit a different page, or wait for it to load, or whatever? um, and if you have this kind of progressive feedback, I think it makes a big difference, because I don't think it matters that much if the decode speed is such that it will be like 50 milliseconds or 60 milliseconds, this type of delays. I think what matters way more is, if you have a slow connection for whatever reason, or a shaky connection, can you show something already, or do you have to wait until the whole thing has been loaded? Um, and in that sense, progressive also is a kind of fallback mechanism, in case somebody does make mistakes of, like, putting an image on a website that is not properly downscaled or whatever. At least if it's progressively encoded, you will still waste the bandwidth, but the user experience will not be that degraded. Um, so yeah, I think for the web this is a very useful feature.
Absolutely. And again, it's the idea that, we consume so much on the web now, and images are just unmistakably part of that process. Uh, just undeniably, it's like you know, people look at a web page with no images and it almost feels weird. It's like, hey, what's missing here? This is all text. Uh, as we wrap up, I did want to ask a few things. So, when possible, I would assume that right now, people who are, say, using like Cloudinary, when possible, they are being served JPEG XL. Would that be a sort of correct statement?
Yeah, yeah. I mean, it's a little bit complicated, but yeah, we are currently serving between half a billion and a billion JPXL images per day.
Amazing.
So it's being used already. This is driven purely by Safari, of course, at the moment. Well, and maybe a few people who are enabling the flag on Chrome, but that's going to be rare. Um, so probably by the time Chrome goes uh, live with enabled by default, we will bump that up to several billion um, JPEG images per day. So yeah, we do have the mechanism of F auto, which is automatic format dispatching. So the server is basically interpreting the request, which does contain, all browsers do this, they send in the accept headers of HTTP, they send out which of the formats they support. So a browser that supports JPEG-XL will say, "Hey, I support JPEG-XL." One that doesn't will not say that. So that's how the server knows what the browser supports, and then we can use the best format for the job. So if needed, we can send an old JPEG as a fallback, or WebP, or AVIF, or we can use JPEG-XL. So that's already supported for a while now, but of course we need the browsers to also support it to really make use of it. And the next thing that we're looking at now is to do dispatching, not just based on what the browser supports, but also on what the image contains. So we can dispatch between, say, AVIF and JPEG-XL, making the best choice depending on the image, because it still depends on the image which one is actually the best. They're relatively close. On average, JPEG-XL is better, but it's typically for natural images, natural photography, that JPEG-XL is going to win. If you have more like synthetic image data, like a cartoon or something like that, AVIF is very strong at that, at doing lossy compression for that. So we might want to do some kind of dispatching based on the image content. That's next plans for my research. Um, so that we currently don't have yet. Currently, it's if the browser supports JPEG-XL, we just use JPEG-XL. Uh, yep.
Oh, amazing. And, I do have experience, sort of like I'd seen so when I was at WebPageTest, we had this sort of integration with Cloudinary, and they would certainly show you, depending on your image, what it would look like as an AVIF, what it would look like as a WebP, and I think maybe at the time I can't remember what it would look like as a JPEG in terms of like weight of the image, et cetera, et cetera, et cetera. So we always knew that was fairly important in providing sort of like the users of web page test the ability to understand like, hey, these are the savings that you can have right now if you go with these one of these modern formats. And it was like this plugin that we had, but it was very effective. So we always knew that something along these lines was gonna come around. But now what you're saying is that you'll be able to sort of like make assessments, pardon me, on the actual content of the image and decide whether or not you're going to go AVIF or JPEG-XL. Now, here's a good question: does that mean WebP is no longer in conversation?
Well, currently we're still producing a lot of WebP, but part of that is for legacy reasons. But anyway, too much detail to. But I think in term, yeah, WebP is going to get deprecated. It's uh, there's very few cases where WebP is for the web really useful if you can also do AVIF and JPEG-XL. So lossless WebP is a nice codec, but on the web you rarely need lossless.
Y-
Um, Even for like non-photographic images, you can now do lossy on them with AVIF and get reasonable results. So there's it's I don't think there's still a strong case for keeping WebP around. I mean, in browsers it will have to be supported for forever, I guess, or at least for a long time. But uh, in terms of us producing it, I think it will slowly fade out. Yeah.
Interesting. So, here's and yeah, again, fascinating conversations. We've been going for like an hour now, so I'm gonna say I want to keep my last question to this one with regards to the formats. Uh, let's fast forward to February 19th, 2027. And, late this year, we've gotten, uh, Firefox, Chrome, stable JPEG Excel support. So now, a year from today, do you see the sort of like web, or yourselves and maybe other CDNs feeding mostly JPEG XLs and AVIFs?
Yeah, definitely. Yeah, I think if we have universal browser support in the major browsers, the bulk of the traffic is going to be JPXL and AVIF, um, and mostly JPXL, I think. But uh, there are still cases where you do need the fallback. There's a lot of user agents out there that are not one of the big browsers, but somebody browsing the web on an e-reader or some other device that has their own old browser, or somebody using some old uh, tablet that hasn't been updated in ages, and but still you want websites to work on those things, and images to load. So I think it will be a very very long time before we stop serving any JPEGs. It will still be needed. The old JPEG and PNG and GIF, I think they will stay around, but the bulk of the traffic will be replaced by JPXL, I think, yes.
Amazing, amazing. Um, Thank you for that. That's been absolutely fascinating. Again, folks, this is really an opportunity to have like an update on what's going on with JPEG Excel, simply because, from the time it was introduced to today, as you mentioned, it was a bit of a roller coaster ride, and the need to have the browsers be in step and support formats is the only way that these formats can kind of grow in usage, and everything else that takes place after that. You had mentioned in the slide a lot of these applications that were adopting it, but some might be waiting for more support. So, uh Jan, people have been fascinated with this conversation. They've been enthralled. They wanna see and hear more. They wanna read some of your research. How do they get in touch with you?
Well, I mean, one way is there's a Discord server on JPXL. So this is a good way to not just contact me, but the community in general. Of course, I'm also on various social media, Blue Sky, X, whatever. And I think I just put up a slide with some links, but of course, people cannot click them on their screen. But these are some pointers. The first one I think is if you really want to dig in very deeply, there's a paper we wrote recently last summer um, on everything about JPXL. It's a very long paper, 73 pages, but it does contain a lot of material. If you want something a bit lighter, there's the links below are blog posts by me about JPXL or various aspects of it. So that's a good starting point to learn more about it. Of course, there's also the website, the jpeg.org/jpxl official website. There's the community website at jpxl.info, and these type of places. I guess you can just search for it, and you will also find.
I'll be sure to post a link, either to, you know, I mean, I could probably post a link to every the link here in the show documentation, so that should not be any issue. But what I see here is a nice sort of like chronological run here from 2020 to last year, which is 2025, and I'm sure you'll probably have some more out later on this year, especially with some of the news we've been expecting. But that should definitely, pardon me, be quite the bit to get people familiar with the JPEG Excel, which, by the way, it does not have a dash between JPEG and Excel. I did
That's
not,
correct.
you know, that I don't know where I picked that up, but it became a habit,
Yeah, I mean, it's written with a dash in a lot of places, like in the iPhone menus and in other places. Officially, it's a space, a non-breaking space.
All right, I'll be sure to remember that. I don't know why, like I said, it's just it feels natural to put the dash in between. Cool. Let me just take that down just like that. Any closing statements from you, sir?
Oof, didn't prepare for any big wisdom to send people away, but I mean,
It's not an awards show, so
it's in the end, it is just a codec, and the main purpose of it is basically to allow you to forget that there is a codec and to just use images without needing to worry about compression artifacts and things like that. So um, I think for me it's very interesting at the technical level and so on, but for a lot of people, the goal really is to just make images work seamlessly. So it's also fine if you want to think about images just as images without the technical details. That's in fact the goal, I think.
yeah,
That should be our ambition to be the goal.
yeah, it certainly should. And I say this as someone, and I think we had chatted about this online. I used to take pleasure in watching people complain about WebP and he when they couldn't share them. They're like, "What is this format? I don't understand. Why do I just see this empty box?" And it was quite comical to see the outrage, literal outrage, when people. Um, eh,
Yeah, probably with JPEG some of that is still going to happen, but maybe it will be slightly better than before because we've had a longer run of getting wider ecosystem adoption before getting into browsers.
Yes.
But still, there will be people with outdated operating systems, and things will not work. It's fine.
Bound to happen. Yeah, exactly. It's hard to compete with other formats that have been around like 30 years.
Yeah,
Um,
yeah.
Jan, thank you very much for today. I do appreciate your time, and especially because it is the evening right now in Belgium, and there are a lot of things that you could be doing instead of like being on a stream right now. But I appreciate your time and the wisdom to share it because this has been sort of like work, and having seen like the potential of JPEG Excel and not being able to sort of like have like the kind of like browser support that is again almost based to what needs to happen for this sort of like wonderful format to help sort of like websites come to this amazing fruition of just lightweight and high fidelity, right? That being said, folks, we are going to close it out right here. I'm going to have, I should have it ready by Tuesday, fingers crossed. But I should have this episode ready for consumption and watching again next week. I'll include the all the links that you just saw right there, so that you'll be able to sort of like on your own time, obviously, do some reading and catch up on the JPEG Excel. I'll probably actually also have links to the repos so that you can keep an eye on what's going on. And but again, they are behind. If you go on Chrome, it's behind a flag. It's behind a flag on Firefox as well, but it is stable on current Safari, which is kind of surprising, and good for them to sort of like jump out and have that supported. That being said, folks, thank you, thank you, thank you, thank you.